Hey, if this is convex, what is this called? Optics, huh? Concave, right? So, okay, so that is also an important point. If f is convex, then minus f is concave. Well, I define concavity as minus of a convex function, right? Okay, so this is clear. So it's very easy to verify whether a function is convex or not by looking at the second derivative or the Hessian rather than going by first principle, right? F of lambda x plus 1 minus lambda y is less than or equal to lambda f of x plus 1 minus lambda f of y. You know, instead of verifying that inequality, you can just take the second derivative, which is like very straightforward, right? Okay. Any questions? Any questions? No? Okay. One more small observation. So if f of lambda x plus 1 minus lambda y is strictly greater than, well, it should be less than, right? This lies below, right? Strictly less than lambda f of x plus 1 minus lambda f of y for all lambda, well, I should not take lambda equal to 0 or 1, okay? So I should exclude that. And for all xy in the domain of f, then f is called strictly convex. That means you cannot have a bucket and then call it as a strictly convex function. It's a convex function, but it's not strictly convex. Why? So let's look at one function like this. Right line. Is this convex? It's a bucket, right? It's a convex function for sure, because you take any 2 point, join, the function lies below. But what about this point and this point? Right? I draw a, okay, so I take this point, I take this point, draw a line and take this point. This height of the function is same as linear combination. So it will be an equality, right? So that means this is not strictly convex because it flattens out, right? If it's not like this, why is it important? Can somebody guess? Since we are studying optimization, why do you think this is important? What is the minima of this function bucket? All the points here, right? There are uncountably many points which are minima. What about strictly convex? Unique, right? The local optimum is also a global optimum and it's unique, right? That's why these kind of functions are important. So we need to study what is known as strictly convex function. So we will see what are the consequences and so on. We will prove that there is only one minima for this. So there are so many interesting things that you can do. Okay, once we study this, we will look at an algorithm called gradient descent, simple algorithm, and a few other algorithms to understand how things work here. And then we'll put constraints and see how to handle those constraints. That leads to duality theory and KKT and so on. And eventually we'll look at other optimization problems as well. Okay, with this I'll stop. Yeah, thanks.